This says to solve. So we solve by graphing. Now we're going to solve the system of equations right here. All right. And I'm going to do this with substitution because y equals 8x and y equals 2x plus 48. So I'm just going to set them equal. 8x equals 2x plus 48. I want to go ahead and subtract 2x to get all the x's on one side. Get 6x equals 48 because that just crosses out, right? Then we're going to divide both sides by 6, and boom, x equals 8. We're not done, though, because now we need to solve for y. I'm going to plug it in the top equation. Y equals 8 times my x value of 8, which is 64. So our answer should be a coordinate 8, 64. But let's see if that's true. Are you ready? So now I'm going to do my check, and I solved in the top, so I'm going to check it in the bottom. So check my colon in the bottom equation, which is my y value of 64 should equal 2 times my x value of 8 plus 48. And that's 16, so I'm going to have 64 equals, and 16 plus 48 is 64. That's a true statement. Check. Let's square our coordinate because it's the solution to the system. Awesome. Move this up a tad. Use substitution to solve the system of equations. Well, this one, I know that x equals my 2y minus 13. So because of that, I'm going to take 2y minus 13, and I'm going to plug it in here for x. So I'm going to rewrite the bottom equation as 4. Instead of x, I'm going to write 2y minus 13 plus 3y, equals negative 8, right? Because that's my 4x plus 3y equals negative 8. Now let's distribute this. So I end up with 8y minus 52 plus 3y equals negative 8. We're going to keep going. I can combine the y's, but I'm also going to get rid of this 52. I don't need it. Plus 52. And I end up with 11y equals 44. Well, that helps, because when I divide both sides by 11, y equals 4. Now I'm going to plug that into the top equation, because I know my x equals 2 times my y value of 4. Oops, that's hidden. Notice I just flipped sides of this equation. Minus 13. So that's 8 minus 13, or x equals negative 5. And that gives me the coordinate for an answer of negative 5, 4. Now I want to check it over here. I solved in the bottom, so I need to check in, or no, I solved in the top, so I need to check in the bottom. And I'm going to get 4 times my x value of negative 5 plus 3 times my y value of 4, and hopefully that equals negative 8. So what do I get? 4 times negative 5 is negative 20. 3 times 4 is 12, plus 12 equals negative 8. And what is negative 20 plus 12? Well, that's negative 8 equals negative 8. And check. It is the correct answer. So I'm going to square it. Make sure to pause as needed. But let's keep rolling. Lots of good work to go through. Okay. 2 systems of equations are given below. For each system, choose the best description. Okay. So I'm looking at these, and I'm assuming I need to try to solve them. Before I can do that, though, I really need to get an opposite. So I'm just going to multiply this top one. Or actually, I'm going to multiply the bottom one by negative 1. And I'm going to end up with, so we still have 7x plus 5y equals 11. That's not changed. But on bottom, I'll have negative 6x minus 5y equals negative 8. Boom, watch this. Add those down, I end up with x, those cross out, equals 11 minus 8 is 3. So that's the first part. I'm going to finish the second part over here just because there's not tons of room. I'm going to plug that into the top, so 7 times 3 plus 5y equals 11, which is, that's just 21. So let's subtract 21 from both sides. And we get that 5y equals 11 minus 21 is negative 10. Divide both sides by 5, and y equals negative 2. Boom. Which means my coordinate should be the point 3, negative 2. Now we can always check it. I know there's not a lot of room here. Just find room on your paper. The test will be similar to this where you won't always have room. You can use scratch paper, or you can just kind of find around the paper. You can do the check right here in the bottom equation. 6 times my x value of 3 plus 5 times my y value of negative 2 should equal 8. So that's 18, and minus 10 equals 8. 18 minus 10 is 8 equals 8. Check, that works great. It's not the most best drawn out problem, but it'll work. Okay, solving this system right here, we notice we already have equal and opposite, so I'm just going to add straight down. That's gone, but uh-oh, so is that. And I'm left with 0 equals 4 plus 5 is 9. Is that a true statement? Not at all, it's not. The system has no solution. And our last problem of the day. Oh, excuse me. So this is y is greater than or equal to negative 3x minus 3. So I'm just going to go down to minus 3. And then negative 3 tells me to go down 1, 2, 3, and over 1. Down 1, 2, 3, over 1. You know I like to. Stair step myself. And it's a solid line because it's or equal to. And then last, it says greater than or equal to, so pen or pencil on the line, shade up, boom, that's this direction. Well, I've just got a case of the yawns, guys. And that is how we do this problem. Now, the last one we're going to do is a system. And the system, we'll graph the first one, is y is less than, so it's dashed line. We'll start at 3, and it says negative 4, so down 1, 2, 3, 4 over 1. Okay, let's do that dashed line. Maybe a little bit better dash than that. It's just a really long dash if you think about it. And it's less than, so I'm going to put my pen on the line, draw it down. So yeah, we're going to do everything on this side. Okay, and let's graph the next one, which has a start value 2x plus 5, so start value of 5. And a slope of negative 4. So 1, 2, 3, 4. Over 1. 1. Oh my gosh, I looked at the wrong one. It's a slope of 2. Y is greater than or equal to 2x plus 5. So it should be start value of 5, but down 1, 2 over 1. No, that's a positive 2. Oh my goodness, up 2 over 1. Whoa. We almost had major problems there. So then up 1, 2 over 1, up 1, 2 over 1, perfect. And I can go down 1, 2, back 1. Down 1, 2, back 1. Look at that. It's okay if you make mistakes as long as you find a way to correct them. Now this one should be solid, okay, where the other one was supposed to be dashed, and I did for part of it. And where the last one was less than, this one is greater than, so I'm going to put my pen on the line, and I'm going to go up, and I'm going to shade everything in this section. And what our solution region ends up being is where they both collide here. Awesome. Okay. Sorry, I like to color that in. It's fun. Brings me back to my kindergartner days where things were simple. All right, so that's the team test. Make sure to go back and look at stuff. We'll talk about it. With that said, peace.